Hi, everyone, and welcome to SQL Server on Azure Virtual Machines Reimagined. In this series, we are going to cover a number of topics that are relevant if you're running SQL Server on an Azure Virtual Machine. And in this particular section, we're going to do a deep dive on how storage works in Azure Virtual Machines. My name is Pam Lahoud, and I'm a Principal Program Manager on the Azure Data team, and I'm the lead PM for SQL Server on Azure Virtual Machines. And I'm joined here by my colleague, David Pless. David, take it away.
Hello, everybody. My name is David Pless. I'm a Senior SQL Program Manager, and I cover Azure Virtual Machine and SQL Server Storage. When customers consider moving a SQL Server workload to an Azure Virtual Machine, what do they typically do? From our experience, many times we are sizing SQL Server workloads by memory and CPU. It makes sense to size by cores as we are sizing based on what we've licensed. Maybe we are also looking at Azure hybrid benefits and are taking the best advantage of this offer. And of course, we know SQL Server benefits from memory, as SQL Server takes advantage of what's cached in the buffer pool, and there are many other SQL Server features that takes advantage of available memory. But focusing on CPU and memory exclusively causes us to miss the opportunity to size based on storage throughput. And this is commonly where customers are needing the most performance. We also miss the opportunity to compare storage throughput from on-prem to Azure, especially when we miss the opportunity to appropriately baseline our SQL Server source performance. The reason these opportunities are often missed is not fully understanding the difference between CapEx and OpEx and how it should change the way we approach architecting solutions in the cloud. This should also change how we measure and interpret the results of our baseline testing. To put it simply, in the cloud, we only want to use what we need. In order to accomplish this, we need to carefully measure source workloads, build a storage foundation in Azure capable of handling our source throughput, choose a virtual machine class capable of handling our storage and compute performance, and finally, understand that as DBAs, we must always be tuning our SQL Server workloads. And with this in mind, Pam, what is the Azure Virtual Machine disk options we should consider?
Thanks, David. So in this section, I just want to cover a little bit about how storage works in Azure Virtual Machines and what your options are for where you can store your SQL Server data and log files in an Azure VM. So this is just a snapshot of what you would see if you were remoted into one of your virtual machines and you were looking at disk management. So you can see that it doesn't look really any different than if you're running a VM on-prem. But the different drives that you'll see come from different places. So the first one is the OS disk. And so this is, of course, the C drive, and this is where the operating system will be pre-installed, along with, if you're using one of our SQL Server Marketplace images, SQL Server would also be installed here. But if you're just using a base Windows image, this is where Windows would be installed. And this is remote storage. So this would be on what we call a managed disk in Azure. The D drive is what's called the temporary drive or the ephemeral drive. This is local to the host that's hosting the virtual machine. So this is hosted on usually some kind of solid state disk, NVMe in some cases, depending on the VM series that you're using. And so this drive is actually local to the host itself. And because of that, it's ephemeral, which means if the virtual machine needs to migrate to another host because there's an issue with the host, for example, or for maintenance, or if the VM is, say, shut down and then gets started up later, it might come up on a different host, which means everything on that ephemeral drive is going to be lost. So you don't want to store anything on the D drive that you can't recover. And then you have the option with an Azure Virtual Machine to add one or more data disks. And these are managed disks that are hosted remotely. So these drives are also persisted similar to the OS drive. So the OS disk and the data disks are what are called managed disks, and the temporary disk or the local ephemeral drive is hosted on an SSD that's attached to the host. So let's take a look at how disk provisioning works in an Azure virtual machine. So as I mentioned, you can have a managed disk for your data disks, and depending on the VM size, you can attach multiple disks. The VM size will tell you how many data disks you're allowed to attach. And these disks have their own limits of how much I/O and throughput they are allowed to serve. And so that's what we call disk level provisioning. So disk level provisioning is how much I/O throughput the disks themselves are capable of providing. We also have this idea of caching in Azure VMs. So if you turn on caching on a disk, then in addition to the disk level provisioning, you also have what's called SSD level provisioning. So this cache is a cache that's hosted on the host machine. It's made up of the local SSD as well as some memory from the host machine. And this provides a caching layer between the virtual machine and the network storage. So this provides a benefit because, and we'll talk a lot more about this later in this session, but this provides a benefit because it brings the storage local to the VM. So we have this local cache that allows us to do faster reads. And so we'll talk a lot more about that later. And then we also have the local or the ephemeral drive, which we talked about, which is also hosted on that SSD. So this is SSD level provisioning. And then we have the VM level provisioning. So this is how much I/O and throughput the VM is capable of delivering to the remote throughput or to the data disks. So you have disk level provisioning, which is what the disks themselves are capable of. You have SSD level provisioning, which is what the cache and the local drive are capable of delivering. And then you have VM network level provisioning, which is what the VM as a whole is able to deliver. So let's start with that disk level provisioning. What are your disk options in Azure? So there are a few different options: standard HDs, standard SSDs, premium SSDs, and ultra disk. I'm going to tell you right up front, don't even worry about the standards. These are not going to be fast enough for your SQL Server workloads. At a minimum, you want to have premium SSD. Premium SSD offers not only premium I/O throughput, but it also has some additional features like that caching that we were talking about. So premium SSD is really what you want to go for most of your SQL Server workloads. We also have Ultra Disk, and Ultra Disk has much higher throughput and IOPS availability for the capacity, and it also has very low latency, sub-millisecond latency. Ultra Disk is a lot more expensive than Premium Disk, though. So you really only want to go with Ultra Disk if you truly need that sub-millisecond latency. So when you're choosing disks for your SQL Server workload, you want to focus on Premium SSD first, and then consider Ultra Disk if you need that low latency. So Premium disks are sold basically by capacity. So you can see on the screen here, I have P30s, P40, P50, P60, P70. So you can see the sizes going up: 1 terabyte, 2 terabytes, 4 terabytes, 8 terabytes, et cetera. So these are your options that you want to focus on for SQL workloads. And you can see as the capacity goes up, so do the number of IOPS and the amount of throughput that each one of these drives is capable of. Now for SQL Server workloads, we want you to focus on P30s and P40s. And let me tell you some basic reasons why that's the case. So first of all, for disk level provisioning, how much IOPS and throughput are they capable of? They're capable of a decent amount by themselves, but you can also pool them together to get more I/O throughput. And we'll talk about that a little bit later in the session today. But the other thing that's important is P30 is the smallest drive that's eligible for reservations, which means that you can save some costs by reserving capacity using P30 and higher. The reason why we want to stay P30 or P40 and not go higher than that for data files is in order to be able to turn on that caching that we talked about, it needs to be less than 4 terabytes. The disk itself needs to be less than 4 terabytes. So you can see here that both P30 and P40 are less than 4 terabytes. They allow for reservations. So this is your sweet spot for the best price performance when it comes to disk level provisioning. And it's okay if you need more than 250 megabytes per second or more than 7,500 IOPS. You can get more by pooling multiple P30s or P40s together using storage spaces. So we'll talk more about that later, but this is probably, for most of you, this is what you want to be focusing on for your SQL Server and Azure Virtual Machine workloads. Now that UltraDisk is provisioned a little bit differently. So UltraDisk, you can go up on capacity, but you can actually configure the IOPS and throughput separately than capacity. So you can choose whatever capacity you need, and then you can dial up or down the IOPS and throughput as needed. So this gives you a little bit more flexibility for what you want VM performance-wise. And as I said earlier, it gives you that super low latency. So you want this for maybe transaction-heavy workloads where you have a very busy transaction log. You probably wouldn't want to put your data files on here because your data files are generally not as sensitive to I/O latency, but your transaction log file might be something that you'd want to host on UltraDisk, particularly if you have a super high concurrency transactional system. But again, most SQL Server workloads don't really need this low latency, so it might not be worth the cost for most of you. So premium is probably where you want to start. So that's your disk level provisioning. And then we also talked about VM level provisioning. So what I have on the screen here is just a snapshot of our documentation for our favorite virtual machine size, which is the EDS v4 size. So if you look at documentation, this gives you an idea of what the EDS v4 series is capable of in terms of capacity. Now, the VM level provisioning is determined by this max uncached disk throughput, IOPS, and megabytes per second. This is how much the VM itself is capable of. So the limits on the P30 and the P40, that's the disk level provisioning. That's what the disk itself is capable of. But the VM also has a limit on it. So you wouldn't want to add more P30s than what the VM is capable of delivering as well. So you've got to be careful that you're not exceeding the disk level provisioning and you're also not exceeding the VM network level provisioning. So that's your max uncached disk throughput, IOPS, and megabytes per second. Next is the SSD level provisioning. So that's that kind of middle layer where the cache lives and where the local drive lives. So there's two relevant columns for that in our documentation. First is temp storage. That's how big the D drive is. So we generally recommend that you put tempdb on the D drive. So you want this, you want to choose a virtual machine that has a temp drive that's big enough to host your tempdb. The other column that's relevant is the max cached and temp storage throughput. And this is your SSD level provisioning. This is how much I/O throughput that you have for both the D drive and the cache together, okay? So since both the cache and the D drive are hosted on that SSD that's attached to the VM host, they're both combined together and they have this limit. So what you'll notice for the EDS v4 series is that they actually have quite a decent sized local drive, and they have pretty high local IOPS and throughput. And that's going to become important when we start talking about things like I/O capping and how these limits are enforced, and how caching can really help you achieve the I/O throughput needs you have for your virtual machine. So I'm going to hand it over to David to talk a little bit more about how I/O capping or throttling works. Capping is the nice term. You might know it as throttling, but capping is the preferred term. It means the same thing. But what David's going to go through is how you can understand how these limits that I just showed you apply to your SQL Server workloads, and then how caching fits in with that.
So we're going to talk about how disk performance works. And it's important to etch in stone that Azure virtual machines have IOPS and throughput performance limits based on the virtual machine type and size, and all disks are going to have their own IOPS and throughput limits. Performance can get capped when the application requests more IOPS or throughput than what is allotted for the virtual machines or the attached disks. When capped, the application may experience suboptimal performance through increased latency. In this example, we're going to be talking about disk level throttling or capping. So consider this. We have an E8 DSV4. This virtual machine has 8 vCore, 64 gigs of memory, but the key piece is that there's 12,800 uncached IOPS for this machine. In this case, we've configured 3 premium P10 disks. There are 3 P10 data disks that support up to 500 IOPS, and assume that SQL Server data, log, and TempDB files are hosted across them. So here's the process. The application makes a request that requires 10,000 IOPS to the virtual machine. Now this is fine because the standard E8 DSV4 virtual machine can handle up to 12,800 IOPS, as you can see on the screen. The IOPS are then broken down. And let's just say that the OS disk is getting 1,000 IOPS, and the other data disks are getting 4,500 IOPS apiece. But this is where we kind of run into a problem here, because all of the attached disks are P10 disks, and they can only handle 500 IOPS. So the disks respond back with 500 IOPS each. The application's performance is then capped by the attached disks, and it can only process 1,500 IOPS to the application. The application could obtain peak performance at 10,000 IOPS if better performing disks were used, such as, let's say, premium SSD P30 disks. Okay, so now we've upgraded our disks from the premium SSD P10s to the premium SSD P30s. We've improved from the 500 IOPS to 5,000 IOPS in 200 megabytes per second, and now the application performance is not going to be limited. The application is getting the full 10,000 IOPS it is asking for because better performing disks were used, such as these premium SSD P30 disks. This is good. No capping is occurring at the disk level. So essentially have solved the problem here. All right, so let's talk about VM level IO capping. So now consider this example. This time at the virtual machine level, we are having VM IO throttling. In this case, we are increasing the application's required IOPS. The application is now asking for 15,000 IOPS. Again, we have a standard E8 DSV4, and the key piece here is that there is again 12,800 uncached IOPS that is allowed for this machine. And we have the same upgraded disks that we've had before, the P30s. The 3 P30 data disks each support 5,000 IOPS. So here's the process. The application is asking for that 15,000 IOPS in its request. The 15,000 IOPS, this case, let's say that they are just broken down in just this example evenly, 5,000 IOPS to the OS, and then 5,000 IOPS to each of the other data disks. All of the data disks are P30 disks, and in this case, they can handle all of the IOPS. So they respond back with 5,000 IOPS each. This is their requested amounts. Now, because the E8 DSV4 virtual machine can execute up to uncached 12,800 IOPS, this limits what is returned to the application. In this case, the virtual machine is capping the IOPS and not the underlying disks. Now, it may not be by a lot, but the application is not getting all of the IOPS it is asking for. Now, what's important to understand here, and I will pause at this situation, is that this is not necessarily a problem I would run to solve. If your user experience is not being harmed by the amount of capping that is occurring here, I would say that this is a perfectly fine scenario. You're very close to the 15,000 IOPS that are being requested. It's not that huge of a difference. If the user experience is not being harmed, I would not necessarily go to solve for this immediately, but it is definitely important to be aware of and continue to monitor, because you are past the limits and you could, as IOPS needs increase, begin to see the user experience diminish. Okay, let's talk about understanding host caching. Enabling VM host caching. You can adjust the host caching to match your workload requirements for each disk. You can set your host caching to be none, which means no caching is going to be used. This is the default when you add a new data disk. You can set it to be read-only for workloads that do read-only operations. This would be your data disk and tempdb files if you cannot fit tempdb on the ephemeral D drive. And read-write. And these are for workloads that do a balance of read and write operations. This is the default often for the OS disk. However, we do not recommend changing the operating system caching policy, and we also do not recommend read-write for any data files, or including tempdb configuration. We recommend that you use no caching at all for the log file. The log file does not benefit from read caching, and you are losing the cache where it could be more useful for other storage needs. So basically, you're only going to be choosing read-only caching or none. Read-only caching for your data files and none for your log files. So let's talk about how read-only caching works for reads. Let's run through a couple of examples of different host caching settings, and we'll see how it affects the data flow and performance. In this first example, we're going to look at what happens with IO requests when host caching is set to read-only, but the data is not available in cache. When a read is performed and the desired data is not available in cache, the read request is sent to disk. Then the disk surfaces it to both the cache and the VM. So this read is counted towards both the VM's uncached limit and the VM's cached limit. Now, how about how host caching works if the data is available in cache? When a read is performed and the desired data is available on the cache returns the requested data. There is no need to read from the disk. This read is only counted towards the VM's cache limits. Now, how does read-only caching work for writes? When a write is performed, the write has to be written to both the cache and the disk before it is considered complete. This write is counted towards the VM's uncached limit and the VM's cache limit. So let's talk about how read-write caching works with writes. Now, looking at what happens with IO requests when the host cache is set to read-write is important to understand. The reads are simple. A read is handled the same way as read-only. The writes are the only thing that's different with read-write caching. When writing with host caching set to read-write, the write needs to be written to the host cache to be considered complete. The write is then lazily written to the disk during a background process. This means that a write is counted towards cached IO when it is written to the cache. When it is lazily written to the disk, it counts towards the uncached IO. Now, because SQL Server has to guarantee that writes are durable, all SQL Server writes, including both the data files and the log files, have a flag set that forces write through. This means that writes must be written all the way through to the disk. This essentially means that SQL Server workloads will never be able to benefit from any type of write caching. So this is why you don't want to enable write caching for the transaction log. You're basically chewing up the cache for writes and never getting any benefit from read operations. So let's talk about how we can benefit from host caching. We're going back to the previous example, but we're going to fix it with caching. Okay. So again, we are using a E8 DSV4. This is 12,800 IOPS uncached, 77,000 IOPS cached, a virtual machine that has read-only caching enabled for the data disks. The application is again requesting 15,000 IOPS. The requests are broken down as 5,000 IOPS to each underlying disk attached. Because caching is enabled for the underlying storage, we can get the 15,000 IOPS from the cache throughput, and we do not run into the uncached limits of the virtual machine. With caching enabled, even at 15,000 IOPS, no performance capping occurs. So Pam, let's talk about choosing the right VM size.
Thanks, Dave. Yeah, I'd really like to move into tying this all together and helping you figure out how do you choose the VM that's going to meet your needs for your particular SQL Server workload. So let's go back to that original diagram I was showing with the different kinds of provisioning, the disk level, the SSD level, and the virtual machine level provisioning. So how do we tie this back to the documentation? So here again, we have our favorite EDSV4 series, and I've circled that E8 DSV4 that David was just walking through the capping and caching demo with you. So first, let's talk about where your transaction log files are going to go. So remember, you're going to have host caching set to none, and so your transaction log files will fall into this uncached bucket. So this is your uncached disk throughput. So that's your, comes out of your 12,800 IOPS and 192 megabytes per second bucket. So that's where your transaction log files go. Your data files will have host caching set to read only. So your data files will be bound not only by the disk level provisioning, but also by the SSD level provisioning, since they are going to go through the cache and also, of course, the virtual machine level provisioning. Then you've got your tempdb, which hopefully you will locate on the D drive or the local ephemeral drive. So this drive has no caching, but it's also not a remote drive. It doesn't hit that remote limit. So that comes out of the SSD level provisioning. So you can see we've mapped out what the IOPS and throughput would be for each level of provisioning. So again, each P30 drive is capable of 5,000 IOPS and 200 megabytes per second. You can combine those together with multiple drives. If you turn on caching, you are also bound by the 77,000 IOPS and the 485 megabytes per second for any IO that's going against the data drive, as well as any IO that's going against tempdb. And then the VM level limit, the 12,800 IOPS and the 192 megabytes per second, both your uncached and your cached drive, so both your data files and your log files will be going through that VM level limit. So this, when you're looking at the VM sizes, this is how you can map things out. And so how do you know whether one of these is going to meet your needs? Well, the best way to do that is to actually measure the performance of your existing workload. So the easiest way to do that is with perfmon counters. But if you have some kind of monitoring on-prem, like say you have SCOM or some third-party tool where you're already collecting these counters, you can use that as well. And so what you want to do is measure your IO and throughput separately for data files, log files, and tempdb, because the target location of each one of those types of files is going to be different. Therefore, the IOPS and throughput from the VM side is going to be different. So you want to measure them separately so you can choose the right VM size. So in order to know what your IOPS are, or your transactions per second, this is IO requests per second, you would be looking at disk reads per second and disk writes per second if you want to monitor the reads and writes separately, which we do recommend that you do. And then there's also disk transfers per second, which is just a combination of reads and writes. Then for throughput, this would be the megabytes per second, the IO throughput, and that's the actual amount of data that you're pushing. You want to look at disk read bytes per second and disk write bytes per second to monitor them separately. There's another counter, just disk bytes per second, and that would be reads and writes added together. So if you want to monitor them separately, read bytes and write bytes, and that will tell you how much IO throughput is generating. Now, SQL Server's IO size is variable. It's not always the same size. So that means that you may have higher IOPS with lower throughput, or you may have lower IOPS with higher throughput, depending on the type of workload you're pushing through SQL Server. Typically, data warehousing type workloads will push higher throughput, lower IOPS, and then your transactional workloads would push higher IOPS and lower throughput. But really, your mileage may vary. It totally depends on the kind of applications that you're running against your SQL Server. And then the last thing you might want to monitor is latency. So this is the time it takes to complete the IO request. This would be average disk seconds per read and average disk seconds per write. And again, there's an average disk seconds per transfer that adds both reads and writes together. So for this, there's not much you can do about latency in Azure. Really, your only choices are Premium SSD or Ultra SSD, which gives you sub-millisecond latency. So I wouldn't worry too much about the latency. One thing to note about remote disk throughput in Azure is it's generally going to have higher latency than what you're used to on-prem. Many folks have like super high-end SANs with dedicated fiber channel networks that give you like super fast, ultra low latency IO throughput. You're probably not going to have that same level in Azure. So you can expect latency to be a little higher in Azure. It's probably not going to have a huge impact on your application. Most SQL Server applications are not that sensitive to latency. For the transaction log, it's a lot more important because that's more directly felt by your applications, particularly if you have like high-speed transactional applications. So if you know you're in that category, then you may want to pay more attention to latency. But I would say for your average SQL Server application, the kind of latency you're going to get in Azure is usually fine. And then you can always look into Ultra Disk if you need to, if you get up into Azure and you decide, yeah, actually this latency is impacting my application. Again, testing is always important, so it's good for you to test once you get there as well. So how do you map these counters to the limits that we just talked about? Well, generally, your uncached IOPS and megabytes per second is going to map to your transaction log reads and writes, because your transaction log is going to be on an uncached drive. But also you need to account for data file writes, because remember your data file, you have to write through to the disk itself. So writes to the data file are always gonna hit the remote storage or the uncached limit. And then depending on how good your cache hit ratio is, maybe let's say 70% of your reads. We're generally seeing that SQL Server workloads get about a 30% benefit from the caching in the VM level. So you can estimate about 70% of reads, but honestly, it could be higher or lower depending on your particular workload and how much you can benefit from the caching. Okay, so map transaction log reads and writes plus data file writes and about 70% of reads to uncached IOPS and throughput. And then your cached and local IOPS and throughput is your tempdb reads and writes, because remember, tempdb is going to be on the D drive, so it's going to be going after that local limit, and plus your data file reads and writes as well, because we need to write to the cache as well as read from the cache. So all of your data file reads and writes have to go through the cache, as well as part of the reads. When you have a cache miss, some of those reads will also go through to the uncached. So you want to take all of these perfmon counters and you want to look at not only the average over time, but you also want to look at your maximums. So you want to make sure that you have enough headroom to handle any spikes in IO that you have. And you also want to make sure that you monitor for a significant period of time. You want to make sure, like, let's say you have like end of month processing or something like that. If you only monitor when you're not doing the end of month processing, you may end up undersizing your VM because, in that end of month processing, you're generating a lot more IO. So you want to make sure that you've got enough data to choose the right size. Now, the nice thing about Azure is you can always size up and down as needed, but it's much harder to do that for storage because in some cases you might have to actually move the data from one disk to another in order to size up or down. So it's a little bit more challenging to size up and down on the storage level. So you probably want to get this right up front. So make sure you're measuring your peaks as well as your average over time. And then, of course, give yourself a little buffer for growth. Okay. So there are a few VM series that we recommend. So if all things are equal and you're just not sure which VM series to choose, we really recommend sticking with one of the memory optimized VMs. The first one is the one that we've been talking about all day today, and that is the EDS v4 series. I can't stress enough how great this VM series is. This truly is the best all-purpose SQL Server virtual machine, and this will give you the best price performance for almost all SQL Server workloads. It's got great remote throughput, those large local drives, high local and cache throughput. It's really great. The M series is for those high-end workloads that really need the highest amount of memory and throughput that we offer. So big data warehouses, mission-critical OLTP, or if you have heavily consolidated servers that have lots of applications going against the same virtual machine, you might need to go up to this M series machine. The trouble with M series is it tends to be very expensive. It's a lot more than that EDS v4 series. So you might want to do some testing with your workload to see if you can go down on the memory a little bit and save yourself some costs with the EDS v4 because you can leverage that great local caching. So it's definitely worth testing if you're not sure whether you really need that high memory in the M series. And then for your more entry-level SQL Server workloads, the DSV2 11 to 15 series is great. This is also memory optimized, but it's a little bit smaller. It doesn't have the same great 1:8 ratio that the EDS v4 series has. And so it's good for smaller SQL servers, lightweight SQL servers, but really, I think if you're in doubt about what to choose, just go with that EDS v4. It is just an all-around great SQL Server VM. So I highly recommend, if you're just not sure what to pick, go with this EDS v4. And then, of course, we would say you want to monitor your workload. You want to make sure that this is going to work for you. But if for some reason you don't have the numbers in front of you, or maybe it's a brand new SQL Server workload that you don't have existing test numbers for, then start with the EDS v4. Okay, so let's kind of tie everything that we've just talked about together and talk a little bit about some general storage best practices when you're configuring your Azure VM. So we mentioned when we were talking about disk provisioning and managed disks that you can pool disks together to get better IO throughput and IOPS. So here's an example on the slide where for the same capacity, 4 terabytes, if you were to use one P50 drive, sure, that would give you the 4 terabytes and it would cost about $450 a month. You could also get 4 terabytes of capacity with 4 P30 drives instead of that one P50. Now, the benefit of going with the 4 P30s instead, it's about the same cost, a little bit more, but look at the difference in IOPS and throughput. When you tie these drives together in a storage pool, you get the full benefit of all 4 drives added together. So you get 20,000 IOPS and 800 megabytes per second of throughput for that same 4 terabytes of capacity, compared to only 7,500 IOPS and 250 megabytes per second of throughput with just one P50. And the other benefit of going with those smaller P30s is that then you get read caching, because remember, any disk that's 4 terabytes or larger is not eligible for caching. So with this one P50, not only do you get less IOPS and throughput, but you also don't have the benefit of being able to turn on read caching. So it's much better to go with a large number of small disks rather than a small number of large disks. pool them together using storage spaces, and you will get the biggest bang for your buck when it comes to configuring storage. So I'll reiterate what we said earlier. You generally want to target P30s or P40s if you need higher capacity, and then pool multiple drives together in order to get maximum IOPS and throughput for your storage. One thing to note is that there is a limited number of data drives that you can attach to each VM, and the number of drives that you can attach is based on the VM size. So when you're looking at the capacity of each of the VMs in the series, pay attention to how many data disks can be attached, because that might change the way you lay out your storage. And also, if you need to grow in the future and you think you might need to add additional drives, keep in mind that you'll still be limited by that number of data drives. So if you size up the VM and you want to also size up the storage, you want to make sure that you have enough drives. So you might have to go with a larger size if the number of drives that you need is high. So let's tie this all together with the storage options that we've covered. So first step, choose the right disk. Go with premium SSD for most of your needs, ultra disk if you need that low latency, and make sure you leverage that ephemeral disk for TempDB. So because that disk is ephemeral, you can't put just regular data files on it because the data could be lost. So TempDB gets recreated every time you restart SQL Server. So it doesn't need to be persistent. So using that ephemeral disk for TempDB is ideal. It allows you to leverage that local throughput from the VM, not have to go against that uncached limit or the remote IOPS, and it's fast because it's on that local SSD. So that's perfect for TempDB. So data files, P30s and P40s on premium disk, ultra disk if you need low latency, typically for your transaction log, and then use that ephemeral disk for TempDB. Next, enable host caching. This is free. It comes with the VM. If you don't turn it on, you're leaving IO and throughput on the table. So you definitely want to first choose a VM that allows for host caching. Second, choose disks that allow for host caching, which is those P30s and P40s, and enable the read-only caching on the disks that host your data files. And remember to set the disks that host your log files to none. And then if TempDB does not fit on the ephemeral drive and you have to put that on remote storage, then that's another disk that you would set to read-only caching. So make sure you leverage that host caching because it's basically free reads. So you don't want to leave that throughput on the table. Next is write acceleration. And we didn't talk in detail about this earlier, but this is a special technology that's on the M series VMs only. So those are those larger, high memory, more expensive VMs. This write acceleration is a way that you can get improved latency even if you're on premium SSD. So the nice thing about the M series is if you don't want to go with ultra disk, but you need that low latency, you can turn on write acceleration. Write acceleration is free. So it's definitely worth turning on if you are in one of these M series VMs. So write acceleration on your log drives. And then lastly, leverage storage configuration. What do we mean by this? In the Azure portal, if you build your virtual machine using one of our marketplace images for SQL VM, we will automatically configure the storage for you according to our best practices. We will set the appropriate storage spaces settings. You can choose how many drives you want to have in each of your pool. We will make sure the disk locations are correct, your data files on one pool, your log files on another pool, and your TempDB on the ephemeral drive. And not only that, but there's actually some steps that you have to execute on the D drive if you want to put TempDB there, because if for some reason you lose that ephemeral drive, the folder where TempDB is located is going to be gone as well. And we need that folder back in order for SQL Server to start. So when you use our storage configuration, we automatically configure a job to recreate that folder anytime the VM is restarted. That way you can seamlessly use that ephemeral disk for TempDB. We do all of that for you. Now you can manually configure that job, and we have some documentation on that, but using storage configuration is just a great way to ensure that everything gets configured correctly right up front. So let's just take a peek at what that looks like. And keep in mind that this is an area that we're working on and that we're always improving. So this might change over time, but right now you can see you can choose your data drive location and you can choose your log storage location separately. You can choose your disk type. It's going to default to premium SSD, which is what we recommend. And it's going to let you choose your disk type. It's going to default to P30, again, because that's our recommended minimum disk size. And then you can just put in how many disks you want. And as you increase the number of disks here, we will tell you what's your max IOPS and throughput once the pool is created with that number of disks. Similar, your log drives, we'll do the same type of configuration there. And then we can use that local drive for TempDB, or you can change this to put TempDB on remote storage if you choose. And then once you set all this up in the wizard, we will automatically create the storage pools for you with all the correct settings to make sure that you get maximum IOPS and throughput from the disk that you've attached to the VM. So this is the storage configuration wizard that's part of the SQL IaaS agent extension when you use a marketplace image for SQL VM in the portal. Okay, so let me hand it off to David again to summarize a few common storage workload pitfalls that we've seen customers fall into. Take it away, David.
Thank you. Yeah, so avoiding common storage, and you could even say sizing workload pitfalls. First is leading with CPU and memory. Really just want to make sure that you're leading with storage, IOP, and throughput for sizing. It is way more difficult to rebuild storage than to just resize a VM. Plus, this is what we find to be the biggest bottleneck in most environments. Next is missing the performance baseline step. Ideally, you should choose the storage solution based on performance history. The source, IOPS, and throughput is really key to getting the storage right. It is recommended to collect your peak IOPS and throughput for your data log in TempDB, and then choose the VM size that can scale to the total IOPS requirement. Once you get the storage solution, you should match the memory and core requirements based on performance history as well. Remember, it is much easier to change and scale your compute than to rebuild your storage. So you got to get that storage right up front. Next is the storage configuration optimization. Storage configuration misses are very impactful. First, not all SSDs are the same. Standard SSDs are significantly slower than premium. You really need premium disk, and you need to make sure you have the block size and interleave set to 64K if you're using storage pools. Fortunately, we do a lot of this for you in the storage configuration template. Also, make sure you pick a VM that supports premium storage caching, and make sure that you enable caching for SQL Server data files and set none for your transaction log files. You can avoid issues by making sure you leverage the marketplace storage configuration wizard, as we've discussed. Burstable disks and virtual machines, this is an area that's definitely evolving, but what I'll tell you is, for your current scenarios, especially for VMs that have built-in bursting, just keep in mind that that when you have this credit-based system and a paid on-demand system, you're going to get that bursting, and you're not going to be able to limit it to a particular time frame. So once you get that, you'll run out, and then you're going to have to wait for those credits to renew, or those credit buckets to renew. So what I recommend is staying away from relying on bursting unless this is just a dev or web server or a proof of concept machine. We don't recommend bursting scenarios such as these for enterprise SQL Server environments. Previous and older generation sizes, I really recommend using the latest VM series, the ones that we've mentioned previously, especially the EDS v4 that we keep targeting. It's just a powerful, excellent machine for SQL Server workloads. And that's where I'm going to start. Otherwise, if I need the big memory for the data warehouse scenarios, maybe the M series. If I'm looking for something smaller as a departmental scenario, maybe the D series in that memory optimized set. but that memory optimized target is really what we're going to be looking at from a series perspective. Last but not least is missing your SQL Server I/O best practices. Use the latest compatibility level for your databases, enable lock pages in memory, set the max server memory for SQL Server, enable instant file initialization, turn on query store, and don't forget features such as column store indexing and data compression. Use those in a targeted manner. Remember, you're still a DBA and even more so in the cloud. And our mantra of always be tuning always hits home. Okay, Pam, back to you. I know you're going to cover a little bit on monitoring I/O capping scenarios.
Great. Thanks, David. Yeah, let's move on to monitoring. I'm sure after we covered all of these topics, you're probably asking the question. In fact, when we go and plan and answer questions when the video is playing, I'll bet you anything people have already asked us this question. So how do I know if I'm getting capped? How do I know if I'm being impacted by these provisioning limits? The best way to tell whether you're having any sort of I/O capping is by using Azure metrics. There are some counters that you can add, and you can add these, and David's going to do a demo on this in a moment. But you can add these to the portal. You can add them to your dashboard. You can set up alerts if you want. And these metrics will help you measure this, because the thing about I/O capping is you can't really see it from inside the VM. This is something that's happening on the host that the VM is sitting on. So you really need to be monitoring these from the Azure level. You can't monitor them from inside the guest VM. So some metrics that are key for I/O capping, at the disk level, you're looking at data disk IOPS consumed percentage and data disk's bandwidth consumed per second. That's your megabytes per second. So this will tell you a percentage of how much of the total capacity of the data disks that you are using. So that's your disk level provisioning. And this will tell you whether or not you're getting capped at the disk level. If you want to see your VM level provisioning and see whether or not you're being capped at the VM level, then you want to be looking at the VM cached IOPS consumed, cached bandwidth consumed, and then the uncached IOPS consumed and uncached bandwidth consumed. So this is going to show you the VM cached IOPS and cached bandwidth will show you the cached I/O throughput, including the local throughput. So this will also include the IOPS and throughput from your tempdb if you've put tempdb on the D drive. So from inside the VM, you can only see the I/O that's being generated by tempdb. You can't see the I/O that's being generated by the cache itself. So this metric will have both of those together. This is what monitors the SSD level provisioning. So that's the cached IOPS consumed and cached bandwidth consumed. And then the uncached IOPS and bandwidth, that's your remote VM level throughput limit. So that would, any of these counters would let you know whether you're being capped at the VM limit. Okay, and there are some other counters that you can use that might be helpful. For example, there's premium cache hit and premium cache miss. So if you want to have an idea of your cache hit ratio against the host caching, you can see that through here. So there's a number of different useful counters, but these are the ones that you want to keep an eye on if you're concerned about whether you've reached the maximum capacity of your system. So I'm going to hand it back over to David, who's going to do a demo for us. And in the demo, he will show you how to use these metrics to monitor I/O capping.
Okay. I have two tabs open. One is showing the recent resources in my Azure portal, and the other one is already on a dashboard that I've already created, mapping out the counters and some other interesting components that I've used to create my own custom dashboard. So what I want to show you is a few things here. I want to show you how to create a custom dashboard, how you can pin these metrics to a dashboard, and also show you how to navigate the metrics in the Azure Monitor under a particular virtual machine. And you can see that I'm targeting this DP SQL Gen 01. So I'm going to go into that virtual machine. And under monitoring, we can see that we already have some key metrics here that has been supplied for us. So I have the average CPU, the total network, the total disk bytes, the average disk operations per second, and available memory already listed here for me. And if you see, I have this pin tool. Now, every time you see this, I can pin this to a dashboard. This can be an existing dashboard or a new dashboard. Now, I've already created a dashboard. So what I'm going to do is just pin a couple of these to something I'm calling my Azure metrics. I'm going to go ahead and pin that. And let's grab the disk bytes as well. And now I'm just going to go ahead and click pin one more time. Now, what I can do is expand, go to my dashboard, and I'm going to change this to my Azure metrics. And you can see that I have some markdown here that is describing some of the information that we're going to be talking about. And you see that I have what I pinned just a moment ago down here at the bottom. So here I'm listing the key perfmon counters. And this is just a markdown window. I did this to supply some information for us so you can review this. This is another one of those scenarios that you can just take a quick snapshot of what you see on the screen. These are the key perfmon counters that we recommend, the disk counters that we recommend, memory, CPU, and if you're going to capture your network, there's key things that you want to look for: errors, discarded packets, and bandwidth, and then what you would look for from a TempDB perspective. But as we've been discussing, we really want to focus on the disk counters to size your target. We're looking at IOPS and throughput to be very key. And of course, you may want to capture your latency as well, but that is not something that we want to focus on as much compared to IOPS and throughput for sizing. For your cache health, and these are the counters that Pam was talking about earlier, and I just wanted to outline this here for us. These are the counters, or the metrics, that is, that we really want to pay attention to. So for Azure Virtual Machine cache health, we have our VM cached IOPS consumed percentage, the VM cache bandwidth consumed percentage. For your uncached, we have the VM uncached IOPS consumed percentage and the VM uncached bandwidth consumed percentage. If any of those get close to or at 100%, we know that capping is occurring. And the same is true for Azure Disk Cache Health. So your data disk IOPS consumed percentage, your data disk bandwidth consumed percentage, your OS disk IOPS consumed percentage, and your OS disk bandwidth consumed percentage, those reach close to or at 100%, you know that capping is occurring. And of course, we really want to be focused from a disk perspective on the data disks. Right? So we shouldn't really be hosting anything on the OS disk. We want to focus on those data disks. And that scenario of Azure Disk Cache Health and Azure Virtual Machine Cache Health, this can only be monitored using Azure Monitor or Azure Metrics within Azure Monitor. Now, the scenarios that I've pinned down here, my CPU and disk bytes total from the overview monitoring tab that you saw me at previously, I can, of course, edit this dashboard, and then I can move these around and resize them if I want to. So we'll go ahead and do that just to kind of give you an idea of the customization that can be done here. Of course, now I can save it. Now, this is, starting to take shape. It's starting to look like a dashboard that I've spent some time on and worked on here. So if I wanted to make this a little deeper, I can then decide to add some additional metrics and maybe make this specific for that particular VM. So let's go back home. And I want to go into this virtual machine. And I'm going to go down to metrics. Now I'm in the virtual machine. I'm underneath monitoring and I'm going to metrics. And the idea here is I'm going to go grab those metrics specific for my storage and my virtual machine cache health. And then we're going to add these counters as well to the virtual machine that we were just looking at, or actually the virtual machine that we're currently under. All I need to do is in the search here, I'm going to type in VM. And you notice I have a list here. I have VM cached bandwidth, IOPS, VM uncached bandwidth, and VM uncached IOPS. These are the core ones that we already wanted to talk about and look at. So in this case, let's just grab these. And I will add a metric. And we're just going to do this for the rest of them. Add a metric. So we're grabbing all of both the cached and uncached metrics here. And there we go. And you can see that there's already a workload. This is why you're seeing some of this information already being populated. I've got some work being run on this machine. So now that I've done this, I can change the line chart if I want to, change it to an area chart. You know, I can do some other customization, but I'm going to take this here. I already kind of like the way this looks. I'm going to pin this to a dashboard. And again, I'm going to go to Azure Metrics. Okay. Let's go back here and let's do the same thing for disk. So we'll just go in here and type in disk. And the ones that we care about is the actually I'm going to say data disk. Here we go. Data disk. And I'm going to look for my IOPS consume percentage. I'm going to add a metric. I'll say data disk bandwidth consume percentage. And we'll leave this here because as we've discussed, the OS disk IOPS consume percentage and the OS disk bandwidth consume percentage, we wouldn't need to focus on that as much as what we're looking for at the data disk level. So let's change this also to an area chart for consistency. And I'm also going to pin this to my dashboard. Now, let's go take a look at what I've done to this dashboard. You can see down here that I have these two now added in. So I'm going to click Edit. And let's just get this to fit in. There we go, just snap it in like that. And I'll click Save. So you see here, I have my VM cache bandwidth consume percentage, all the other counters here. Now, if I click in here, I'm going to go directly to the scenario that was previously at. This is essentially the drill down into my metrics. This is really nice about having this custom dashboard is you can always do this, right? And we're looking over the timeline. In the timeline, if you notice, it's following the CPU and disk bytes total, the ones that I pinned from the overview page earlier. You can drill in here too. So this is really nice in being able to create something custom. Okay, so now let's go and look at the dashboard that I've built previously. And we'll talk a little bit about how these metrics are getting impacted by the workload that I'm running on my virtual machine. So here I have my VM cache bandwidth consume percentage. This is all at the VM level. And I want you to note that the cached bandwidth consume percentage is being capped. You can see that at 100%, as well as the uncached bandwidth consume percentage. So my virtual machine is being capped or throttled. However, if I look at the disk level, notice that the disk bandwidth consumed percentage is about at 66, 67%. And my disk IOPS, well, actually, the IOPS are really low at this point. The highest it looks like the IOPS got to is around just over 40%, 45%. So clearly, in this case, we most certainly have capping occurring at the VM level. I need to resize this VM or tune this workload. This is not a disk capping situation. Actually, this is the easier scenario to solve for because I have prepared my storage very well, done a very good job of preparing my storage. All I need to do is resize my VM in order to address this capping situation or tune my workload. So this is a really good view on how to use the Azure portal, create a custom dashboard, pin your metrics to a dashboard, and then leverage your metrics to analyze a caching health scenario for your virtual machine and your storage layer. So let's talk about our Azure SQL VM storage best practices. And this is really a summary of everything that we've been talking about here, with some call outs to our documentation and our other DPS sessions. First is obtain perfmon source metrics. We always recommend using Performance Monitor to capture a good baseline of your SQL Server source health. It doesn't matter how you get your perfmon data. You could use SQL Diag, Perf Insights, or another approach. As long as you get a defined peak workload of your regular business performance, your organization's reporting and or ETL windows, your SQL Server maintenance windows, potentially night or end of period processing and so forth, you really want to get these windows in separate captures so you can analyze them separately. Now, regarding the performance counters themselves, we recommend getting your disk counters as a foundation you'll build upon. This is what you're going to be building towards for your target system. And then, of course, add memory CPU counters for the OS process and SQL Server workloads. For specifics on which counters to obtain, please see our DPS sizing deep dive session and refer to our best practice documentation that we have at the end of this presentation. For the second one, choose the right disk. Again, we recommend using premium storage for Azure SQL virtual machines. Start with P30s or P40s for your SQL Server data files. The reason for this is that data caching is not supported for disks larger than 4 terabytes. And if multiple disks are attached to your VM, each disk that's smaller than 4 terabytes will support caching. So the P50 and larger disks do not support disk caching. And since the log files should not be configured for caching support, you could consider P30s and P40s as a start for the cost to capacity benefits, but then you can go all the way up to P80. That would suffice. Remember, storage pools in a storage space will be used to increase the capacity and the overall IOPS and throughput that SQL Server can access beyond the limits of a single disk. For our next one, isolate files. It's recommended to separate data, log, and tempdb files, and the primary reason is that we support and configure these files differently, especially in Azure, but it's also beneficial to separate these file types as their workload patterns differ. And this isolation also helps us with monitoring. For the next one, enable host cache. As we've stressed, enable read-only caching on data files and use no caching for your log files. There's no benefit for enabling caching on log files. This is also why we say to separate your data and log files on different disks, because we enable caching at the disk level. The next one is SQL I/O best practices. Remember, you're still a DBA, and it's even more important in Azure. So use column store indexing, use data compression, make sure your applying your missing indexes and removing those that are no longer beneficial. Maintenance must be done and scheduled appropriately, and follow the best practices we have on our Azure SQL VM checklists. It is more important now than ever. Remember ABT, always be tuning. For next one, leverage the ephemeral disk. Leverage your ephemeral disk for TempDB. This is our best practice. The only reason why you may want to leverage Azure remote storage instead of using the local ephemeral disk is for capacity reasons. There are rarely cases where we would recommend otherwise. The next one is the storage wizard configuration. Use the Azure Marketplace images and the storage configuration wizard. This is an area, as Pam said, that we're making a lot of improvements, but at this very moment, you're getting at least 80 to 90% of all of your critical best practices by using the transactional processing template. This includes everything we've talked about and the areas that we didn't cover, such as the number of columns, your block size, interleave. All of your critical best practices are covered using these templates, and we get the best customer feedback for customers that are using Azure Marketplace templates and the storage configuration wizard. Last, and certainly not least, is leverage Azure Monitor. Use Azure metrics to get the VM and disk cached and uncached health, the OS and disk threshold health, and the virtual machine threshold health. These are the core metrics that Pam covered, and you also saw in my demo. I cover these counters and how to add them to your dashboard. This is the most important counters to leverage for Azure cache storage health for both the virtual machine and disk level, and it's the best way to identify if there's any capping occurring. We're recommending getting deep into the Azure Monitor where you can build your own dashboards and customize your monitoring experience by pinning the metrics to any custom dashboard that you want to build. And then additionally, we recommend understanding log analytics, alerting, and insights, and build this into your monitoring strategy.
Sounds great, David. I think that covers all of our best practices. So the only thing left to do is ask us questions. So hopefully, as you've been watching this video, you've been asking questions in the chat, and we'll be there to answer questions. But if you have any additional questions now, we should have some time to answer those in the chat. If you're watching this video later and we are not here live for the chat, please do feel free to hit us up on Twitter. I'm SQL Goddess, and David, your Twitter handle is?
D+.
D+. And so you can always hit us up and ask us questions on Twitter. So before we leave you, just a few helpful links, some of our best practice documentation. Everything that we covered here today is all fully documented in our documentation. So there's some short URLs here, and I'll leave this slide here long enough in case you want to take a screenshot of that or a picture with your phone. That's what one of those get a picture with your phone slides. And then special thanks to me, us, Microsoft. Yay, for supporting DPS and Data Platform Geeks. And most of all, thank you to all of you for listening and for asking your questions. And we're really happy to be able to talk to you today about what we are working on in Azure SQL VM. Please don't forget to give us your feedback. We are always interested in hearing what you thought about the session, what we can change, what we can do better. So give your both session and conference feedback to the DPS folks, and follow them on Twitter as well as us. And thank you so much.
Take care, everyone.